Okay, number 21 is what's called a difference quotient, and it's kind of supposed to be getting you ready for limits, but I really don't like them. But we're going to go ahead and find the answer, then we'll talk about limits. Okay, so if f of x equals the square root of x plus 4, find and simplify f at 2 plus h minus f at 2 all over h. So the first thing I'm going to do is substitute 2 plus h in for the x here and 2 for the x here and rewrite our expression. So this is 2 plus h plus 4 minus the square root of 2 plus 4 all over h. Then we're going to simplify the square root of h plus 6 minus the square root of 6 all over h. Now I can't do any simplification right now. The h's can't cancel directly. So I'm going to use the difference of two perfect squares trick. So I'm going to make this h plus 6 plus the square root of 6 divided by itself, square root of h plus 6 plus the square root of 6. So in the numerator, I'm going to get h plus 6 squared, or the square root of h plus 6 squared, which is just h plus 6. And then minus the square root of 6 squared, which is 6. And then in the denominator, we're going to have to keep everything. So the square root of h plus 6 minus the square root of 6. And then, of course, 6 minus 6 is 0. So now, writing down every step, we have h divided by h times, in parentheses, square root of h plus 6. This is supposed to be plus, and then plus the square root of 6. And then h divided by h is 1, as long as h ain't 1. Go away. Okay, so now we get 1 over the square root of h plus 6 plus the square root of 6. And we'll go check that answer. So 1 over, they still have 6 plus h, but almost everybody would rewrite it as h plus 6. So there are the steps, pretty much the same steps. We did a little bit of order difference. So that ends the answer here. But the question comes up, why in the world would you want to do this? This makes no sense to me. And here is the reason we would do this. So the definition of a derivative is f prime of x equals the limit, and I like using c approaches 0 of f at x plus c, they're using h, minus f of x all over c. Okay, so if we make our f of x the square root, I'll go back and make sure, so square root of x plus 4. Okay, and we substitute into this limit definition, f prime of x equals the limit as c approaches 0. So this is going to be the square root of x plus 4 plus c minus, and we're using the actual function, the square root of x plus 4 all over c. So we can do nothing right now. Okay, but I'm going to multiply by 1 in the form of the square root of x plus 4 plus c minus the square root, or the plus the square root of x plus 4, and then same thing, x plus 4 plus c plus the square root of x plus 4. So we now have to carry the limit notation with us. So this is going to be x plus 4 plus c, and this is going to be minus x plus 4, and then divided by c times the whole thing, x plus 4 plus c plus the square root of x plus 4. Then limit again as c approaches 0, so the x is going to go away, the 4 is going to go away, so we've just got c in the numerator, and then c times the square root of x plus 4 plus c plus the square root of x plus 4. And now we're going to do an additional step that we didn't do with the, well, we need to still cancel the c's to 1s. So we're going to do an additional step that we didn't do when we're just doing a difference quotient. So this is the limit as c approaches 0 of the square root of x plus 4 plus c plus the square root of x plus 4. Okay, so if I let c go to 0, I'm not causing division by 0, so that's okay. So I get 1 over the square root of x plus 4 plus the square root of x plus 4, which is 1 over 2 times the square root of x plus 4. And if you've had calculus, our function was the square root of x plus 4, which we could rewrite as x plus 4 to the 1/2 power. And if we use the power rule and the chain rule, so my inside function u of x is x plus 4, so the derivative of that by the power rule is just 1. So my derivative of f of x is going to be 1/2 times x plus 4, subtract 1 from this exponent to the negative 1/2 times the 1, which we'll just leave out. So that's 1 over 2 times x plus 4 to the positive 1/2, which is exactly the same thing as 1 over 2 times the square root of x plus 4. So that difference quotient is supposed to get you ready for doing this limit stuff, but I say just go to the limit stuff. But that concludes this video.